Academic peer review. Publish or perish. The currency of the academic world. Don't worry. Academic writing and peer-reviewed publication is a skill that you can learn. I guarantee you, no one is really naturally good at writing peer-reviewed articles using technical scientific language that's field-specific. It is something that you can learn, and you have to just be open to receiving feedback as you submit your first drafts. And you can also look at what's already published to kind of work out the styles and the phrases and the organization of the papers in your field. And we'll talk about that in more detail as we go through how to publish a peer-reviewed paper. The first thing that's very important is, of course, how do you know if you have data that is worthy of peer review? So I always used to think about it as, do I have something that is the best of something, a new thing of something, or do I have like a world record or something? Like one of my peer-reviewed papers was about a solar panel, and even though the ultimate efficiency wasn't the best, it was the best for the polymers that I was using as in the conductive layer. So that's a kind of good place to start, unless it's a review article. A review article is a different beast altogether, but today we'll be talking about like, how do you publish your science, your new thing? And remember, it has to be novel. So is it new? Is it novel? Is it the best of something? That's when you kind of know you have a peer-reviewed paper to be written. Maybe it's more efficient as well. Maybe it's a new insight. Maybe you're combining two things like never before. And yes, that all of those should be triggers for you to be like, okay, I can peer review this. And the next step is kind of putting together a single phrase. Like, for example, if someone was going to talk about your paper, what would they say? So, for example, in my academic past, people would say, this is the paper that contains the best efficiency for these polymers. And it could be that, okay, this paper, another one of mine was, this is a paper that shows the first time of how to produce a transparent electrode using roll-to-roll solution processing with a high efficiency. That's really what you're trying to capture in a paper. So just bear that in mind. Now, you can change it as you go, but those are the important things: is what's best new or a first thing, what have you improved upon that you need to tell the scientific community, and then how would you wrap that up into a single sentence, or it could be a long sentence, but one or two sentences, so that people go, oh, have you read the paper that blah blah blah? And that kind of just gives you an idea of, yes, you're ready to write something for peer review, but also what the overall kind of story should be. And don't overcomplicate it. This is just for you to get a handle on what you are reporting in this peer-reviewed paper, and then you can go on to the next steps. This video is brought to you by my newsletter. Go check it out at andrewstapleton.com.au/newsletter. And about 1 to 2 months, I kind of send out something. I don't like to spam people, so only if I've got valuable information do I like to send one out. But I have got a secret project that I've been working on that will benefit you, and all of the newsletter subscribers will be the first people to find out about it. It's very exciting. I'm excited about helping more of you get better in academia and also make PhD candidatures work for you. All right, go check it out. I'll put a link in the description, and I'll update you very soon with my awesome little project. I'm very excited. Once you have the kind of overall story, if you will, of this paper, you should then start putting together the data, the figures, the research, the tables. Like, you should start putting that in order. Now, I loved starting with figures and tables. figures and tables, I'm a very visual person. And so having the figures laid out one after another allowed me to kind of work out how I would connect this science story. Because a science story is essentially problem, like background, which is your introduction, problem, this is very hard to do, or this has never been done before because of these limitations, and I've done it, like solution. And then you can kind of look to the future, recommendations and limitations and all that sort of stuff. But those are the important steps of a science story. And I like to think about the results section as kind of the this is what I found part, the solution part, of the problem that you're presenting in your research paper. And I used figures and tables. I loved producing a figure and then a table. And then whatever you need to do to tell that story, whatever you need to do to show that you have actually done that thing, I found it really easy to create a paper once I'd kind of worked out which figures and which tables and which data should be shown, and importantly, in what order. Once again, this can change as you go, but you just want to get that first thought structure down on paper. And then after I've done that, I look at the outline. Okay, so once you've got all of your figures and tables together, and you're kind of confident that you can show your story with just that data, like you don't need any extra stuff to show and prove that you've done this thing, I look at outlines. Now, outlines are going to be very field specific. Generally, it's like abstract, introduction, methodology, which can be at the end. Then it can be results, then it can be discussion, or it can be results and discussion, and then it's conclusions, acknowledgements, and then right at the very front is the abstract. I'm not sure if I said that. But that is the overall structure. Now, one thing I really recommend you do if you're going to be in this academic game for a while, if this is your first paper, this is a tip I built up while I was doing science writing at Cosmos magazine. And what I would do is go and print off no less than 10 of sort of the most well-known research papers in your area. And what that does is it gives you an ability to get an idea of how science is reported for your specific field. Now, with those 10 papers, in the margin, I would write down what they are trying to achieve and show in each, let's say, section, and then if you can, each sentence or bit. So that was really useful for me when I was doing science writing, is I looked at the top 10 science articles and I noticed a pattern, and maybe you can find the same too. So for example, in your abstract section, you could be like, okay, what does the first sentence say? What is it trying to portray to me? And just take a little note in the margin. What does the second sentence say? Okay, and what you'll find is that over the 10 papers from your field, you'll be able to come up with a template which will absolutely boost your ability to pump out papers in the future, because you'll have a template that you've got, and you can say, okay, in the first sentence, I give a general summary of the field, or in the first sentence, I say the biggest, most important aspect of this research, or a lot of times, I give the broadest kind of positioning statement for my research. That's going to be super valuable for you. It's going to take a little bit of time to develop that template, but once you've got it, boom, you're in. It's going to be much faster. So that is what I highly recommend, and I don't see enough people talking about it, is just create a template for a paper based on the papers in your field, and you'll have a structure ready to go. And so after I've got the figures and tables for my paper, then I just go through and I just create the headlines, abstract, introduction, experimental, results and discussion, conclusion. And what I find is that if I have headings, and then I take each heading and I do a subheading. So for example, under results and discussion, you can say, well, really, to get my story out properly, I need to talk about these 3 areas, and you can put subheadings. And what you're doing really by doing this is you're making it easy for you to know exactly what you need to talk about where. So figures and tables first, headings next, subheadings if you must, and I think most people should use subheadings. And then when you come to do the actual writing part, the story structure is already there, and you just need to focus on the technical portrayal and delivery of that information, and not the overall structure. So we're going from broad strokes and we're getting smaller and smaller and smaller. But you do not write a research paper in the order that it is presented to the audience, because that is not the most efficient way to write it. Let me explain. Okay, here is the perfect order for writing your research paper. The first thing you should write is the experimental. This is kind of where I started every single time. Once you have the experimental section for your first paper, to be honest with you, a lot of the time you can just copy and paste to the next paper, because the instruments you use, the methodologies you've used, are going to stay approximately the same throughout your PhD. You're going to add new things, you can do things different ways, but the equipment may stay the same if you're in chemistry or the hard sciences, and the methods may change, but that's relatively easy to change. So once you've got a good experimental section, you can copy and paste that across, and also you can copy and paste it into your thesis at the end if you're not doing PhD by publication. So experimental is easier to write. It's very kind of boring and dull. I mean, the whole thing, to be honest with you, is a bit boring and dull. For me, that's my opinion. Some people love it. And so yes, experimental, it gets that momentum up, it starts seeing progress, and that's where you can then go into the results and the discussion. The results and discussion now, remember, you've already got your figures and tables laid out in the order that they appear. So you've got your figure 1, figure 2, table 1, figure 3, all of that stuff is laid out. And what you've got to do is think about, in terms of your overall story, how do I, tie this all together with words? And I like to build out from the figures. So I like to say, in figure 1, you can see that blah, blah, it is shown that, whatever you have to do to explain that figure, and you'll notice that your paper bloats out very quickly. And at the moment, that's what we want. We will go into the editing stage at the end and cut out the fat. And to be honest with you, it's better if other people do that for you, like your supervisor or other collaborators. But at the moment, you are just chucking in descriptions of those figures and descriptions of the tables. What makes them important? What helps tell the story? That is all you're trying to do at this point in the results and discussion section. Just point out what should the viewer or the reader see, and how does that impact on the overall story? And that is very important. So results and discussions next. Then I like to do the conclusions. The conclusions should go to that kind of really simple, story again. So conclusion is bullet point them initially. Underneath the conclusion heading, you say, I have created the world's first blah, blah, blah. We have synthesized the first version of blah. We have done we have made something more efficient. All of that stuff, that is your first overall heading. And you're probably looking at like 2 to 3 conclusions overall, and just bullet point them initially. And then once you're happy that you've got all of the main conclusions out, so mine was, efficient electrode made from solution processing, and a roll-to-roll method. And we had working solar cells. So, 4 conclusions. Those were the 4 things that I wanted people to get from my paper. And then I was able to flesh out each of those bullet points into a simple kind of, 2 or 3 sentences each. But it keeps you focused and keeps you make sure that you don't sort of like start going, and we did this, and we did this, and we did this, which quickly blows out a paper and makes it completely unfocused. Okay, the next thing you should write is the title. The title is a very tricky thing, and I think scientists don't use titles to their best effect, because we're so into our fields. We don't think about the fact that the title is essentially the clickbait for the paper. Sometimes, if you can get a good paper title, people won't even read the paper, but they'll cite you based on the title. I know of people's papers who are being cited through the roof because because the title is just amazing. And then you look at some of the sites and you're like, that's not what that paper says. So titles should be about sort of 10 to 15 words, and it should just sort of give someone the snapshot of what you've done. And do not worry about, using words like, novels a little bit too kind of cliche these days, but, a first attempt, or our first, or the world's first, just play with different power words until you are able to get a title that makes sense, that tells the reader exactly what you've done in a succinct way, but also gives them a reason to continue to read the paper. So it could be, the most accurate blah, or it could be the highest efficiency blah, using blah de blah, that sort of thing will help people understand exactly what the paper's about. Don't use acronyms, don't use any field-specific terminology. Anyone, including your mum, dad, grandmother, should be able to read the title and go, okay, I think this is about solar cells, and you've made them better, for example. And yes, that is a little trick about titles, and if you get it perfect, like I said, people don't even read the paper, they just cite you because it's a good title, guaranteed. All right. The next thing I write is the introduction. The introduction starts broad. So quite often you'll see the beginning of many papers start the same. If you're in a certain field, solar energy will help combat world energy crisis, or peak oil production, or whatever it is. But once you've read those 10 papers in your field, they'll probably mostly start the same, and you can start in a very similar fashion. And then so you start as broad as you can to give the first context of the story to the person reading it, but you very quickly sort of narrow down. You go from solar energy and the energy crisis, and demand for energy is increasing, and then you go, solar energy will create a certain amount of this is my paper, and then a subset of that solar energy is solution processed niche applications, and for that they need blah blah blah. And so you kind of start broad, you go down and go down. Like I said, have a look at papers in your field, which will give you exactly how quickly to kind of narrow down, but also where to start and where to finish. But remember, you should finish at a logical point, which means then you can say, so that's why we did this study. Because otherwise, you need to kind of give people enough information in the introduction that makes them understand why you're doing what you're doing from very broad principles. And then they want to go, okay, well, what did these guys find out? How did these guys help? You can kind of, I don't know if it's called a cliffhanger or what it is, but it's certainly trying to encourage people to read on. And then, if they want, they can just skim right to the conclusions, which is what I did a lot of the time. But yes, introduction, broad, reverse pyramid, come down to very narrow to what this paper is actually about. Lastly, the abstract. The abstract is the thing at the top of the page. Maybe it's about, I would say about 300 words max, and it should give you a perfect summary of all of what you've just written. So the abstract is probably one of the most difficult things to write. There are templates online that you can find where it says, in your first sentence, say this, second sentence, talk about the main key result. Mine was, we produced a solar cell efficiency with blah, or we had a transparent electrode with 4 point something ohms per square resistivity. All of this stuff is very important. You just sort of blurt it out in that abstract, and that is very important. And the last thing you write, even after you send it off not for peer review, for checking with your principal investigators or your collaborators, you send your draft paper to them, and then the acknowledgements is the thing you write just before you send it off. And the reason you do that is because maybe someone has been particularly helpful. Maybe they've got some grant money. Maybe there's been someone who you do want to acknowledge that isn't sort of hasn't put enough information or enough effort into the paper, but to be on the author list, but they do need to be acknowledged. And also in there, you tend to acknowledge grants, any people, and also any institutions that have enabled you to help. Like it was microscopy and microanalysis unit. I used to thank all the time in my acknowledgements, because they, without their support, I was never able to characterize my solar cells. And that's it. So that's the order you write. In short: experimental, results and discussion, conclusions, title, introduction, abstract. Send it off to get people's comments, get it back, write your acknowledgements. Done. Once you have written out your first draft, do not let perfectionism stop you from sending it out to people immediately. It's really tough. We tend to be very perfectionist in the academic world, and we need to be very accurate, but you need to get feedback very quickly on your peer-reviewed paper, on your paper for peer review. So send it out to your supervisor, send it out essentially to people that are going to turn it around quickly. Now, do not send it to a supervisor, your primary supervisor, if they do not send it back, quickly. I always just say, get this back to me within a week. Max, because you need to keep that momentum going. And it helps them, it helps you, but some people just sit on stuff for ages. So if you've got a supervisor like that, don't hold the paper up in that area. Send it to someone who can look over, make sure it makes sense. Postdocs are really good for this because they've got a little bit more experience. I ended up writing 14 or 15 papers in my time. So, I kind of started to understand how it worked, and I was always happy to look over PhD students and other sort of researchers' papers to give them feedback. And my friend Christopher Gibson, Dr. Christopher Gibson, was amazing. He'd always get papers back within 2 days, which was awesome. So yes, don't worry about perfectionists. Don't worry about people picking it to pieces, because it's either they pick it to pieces or the peer reviewer picks it to pieces, and it's better that you get the feedback and you can change it before the peer review process. So stop perfection, get it out there, accept what comes back, learn from it, and go from there. When do you know it's actually ready to publish? I had a little rule, which was essentially that if collaborators started changing each other's words, that was probably a good sign that, they're just changing each other's stuff now. So that's fine. As the first author, it's probably up to you just to be like, okay, we're just going around in circles, stop. So if I noticed that either not many corrections came back, or that the corrections weren't necessarily about the research, but rather it was about, someone's ego about, well, normally I say it like this, or it's my pet peeve that people do that. Yeah, it's your pet peeve, it's no one else's. So as long as they're not tackling the science and people are just sort of correcting words or phrases or whatever, but it still makes sense, that's the time that I used to pull the plug and be like, it's being submitted. And then I would take the normally Word document and I would format it in the way that the peer-reviewed journal wanted me to format it, and that's how I did it. So that is the entire peer review process in a very short time. I have created a summary which is suitable, hopefully, for the majority of PhD and research fields, but there are tons of tiny little things that you need to know about your research field. So go ask questions, go get help if you need it writing a peer review paper. Remember, you're not expected to know this. It's not particularly intuitive. It's technical, dense. It's not the best way science could be reported these days, I believe. So do go seek help, and you will get better as you produce more and more. My first paper was essentially rewritten in its entirety by my supervisor, and I learned as I went. And I was like, okay, well, that's why they changed that. And I would always get comments like, don't put the cart before the horse. I guess I don't quite understand still what that means, but they changed it nonetheless, and it got published in a peer-reviewed journal. So let me know what you would add to that, and I shall see you in the next video.